Hi, today I want to show you NiftiView, a 3D medical image viewer made for amateurs, clinicians, scientists and coders. And I will show you NiftiView based on 4 use cases, one for each user group. But first off, if you haven't already, go on the NiftiView homepage as shown here. Hopefully there's a link in the YouTube video. And then you have to download NiftiView via this link. It's just a simple file. Then unzip it and then double click on it and do a bit of extra stuff which is written down here. And then you can start and go along with the tutorial. Once NiftiView is downloaded, you can just open it by double click. And then we can display our image files. If we are lucky as an amateur, we get .nii files. If we are unlucky, we get big folders with many files in them. How to display them, I will show in the next use case. But for now, use these 4 .nii files and just drag and drop them in and increase the height a little bit because it's a little bit small. And now we see 4 different images displayed in a nice grid. And first off, let me show you how to navigate a 3D image, because we have now 3 different dimensions of the image. The first one is the sagittal plane, left to right. And as you can see, we can navigate by using these sliders, then the coronal front to back plane and the axial bottom to top plane. And as you can see, one of the images has a lot higher resolution than the other ones. It's this one, and to only display the one image I will use max samples of 1, and now we have 4 different pages, one for each image. We can go through them by clicking next and previous. And now as an amateur, the natural final goal of this exercise is to save the image in a normal image format, not the .nii nifty format. So we will go to save image as, for example, PNG, and let's call it my brain. And it worked. We have our image in this nice format. If you want to change the layout, you can also go in here. And suppose we want the coronal plane displayed the largest, we can go coronal ++ or axial ++ if we want to have the axial plane displayed the largest. Another interesting use case is exporting or saving it as a GIF, and that you can do by save GIF. Let's again call it my brain. And then it will go through the largest plane, and then you can see all the 2D images that were taken through your 3D brain or whatever organ was scanned. And to streamline this a bit, there are also the options save all images. Let's do that. Pick a folder, and then all my 4 nifties I have drag and dropped into NiftiView are saved as PNGs. And when I do save all GIFs and pick a different folder, we get the respective GIF for each of the 4 nifties. And let's take a look at this one. And as you can see here, he's not going through the sagittal plane. Instead, because it's actually a 4D image and the 4th dimension is the time, it will go through that dimension, and thereby I can view the movie of my brain in the scanner. As you can see, my eyes are moving here a little bit. Yeah, pretty nice. So that's the amateur use case. Instead of nifties, clinicians often use DICOMs. DICOMs are folders with many files in them, and to easily handle those folders, we will convert them using NiftiView to nifties. That's pretty easy. We just use the uppermost folder path here and create a new folder as the output. And copy and paste its path here. And then Control N will create the nifties in the output path and display them. Let's make it a bit larger. And now we as clinicians often want to know where in the image we are, and this is done by using the crosshair. So now we can see where in the 3D image the slices are displayed. And there are also more overlays like that. For example, if you want to know exactly the coordinates, you can display them like this. And as you can see, it also supports click and drag to more intuitively navigate in the image. Let's undo that. It also supports using the arrow keys, so left and right and up and down. And to go in the coronal plane, you do Control left and right, and in the time domain, Control up and down. Another overlay is the header, what's in the header of the Nifty file. And as you can see in the header of the Nifty file, there is the dimension of the 3 or 4-dimensional array and its data type, so in this case an integer, and the orientation of this array with respect to the scanner coordinate space. But let's undo that and let's show the histogram, which is showing you the distribution of intensity values in the image, which in this case goes from 0 to 58,825. And as you can see, most values are in the lower range. And if we enable the color bar, we can actually see, let's move it a bit, that in this 2D image, the brightest pixel is has an intensity of, let's say, 35,000 or above. So what NiftiView did in the background is determined a threshold above which intensities higher than 35,000 are all displayed in the most white this display can display, so the highest brightness. And we can change that, and often clinicians do, to improve the contrast of the image by changing this value range. So a clinician would go in and change the lower intensity threshold and the upper one systematically to improve certain tissue contrasts. And we could also do this using the percentile range. Let the upper percentile be the highest percentile, and now you see the image is much darker. Let's remove the crosshair. And that's because now the highest, the brightest pixel is actually the highest intensity shown or found in the entire 3D image. NiftiView gives you another feature to systematically improve contrasts, which is equalized histogram. First off, it will look a bit weird. Let's just display the one image to show it a bit better. But if you now change the percentile range, let's change it to, let's say, 60, you can see the contrast is a bit improved. This depends on the MRI you're looking at, but for some MRIs, this greatly improves the contrast of the tissue. And there are also shortcuts for this. You can use Control D and A to change the lower percentile range, and Control S and D for the upper percentile range to adjust the contrast. Neuroscientists often want to display their statistical results on top of a typical brain, and this typical brain is called a template. This is the MNI template often used, but NiftiView also offers the T1 template and the CH2 template. We stay with the MNI template for now. And besides statistical results, often atlases are overlaid on top of templates to indicate different brain regions. So you can also do this with NiftiView. It offers you different atlases to choose from. But for now, let's clear this and add a statistical result on top of this template. I have one here, and let's drag and drop it in. Oops. And as you can see, the results are confined to a small region in the brain. Now we have to uncheck this atlas because NiftiView expects atlases as masked at first, but now we have continuous values in this statistical map, so we have to uncheck that, and also have to check move to a continuous color map. Instead of glass bay, we use hot. There are many different color maps to choose from. You can see them using the catalog. And if you want to use a different color map, you can just copy and paste the name into this box, and then you would use a different color map, but for now I think hot is fine. And on top of the overlay, we also want to know what values these different colors indicate, so we have to use the color bar as an overlay. And let's move it a bit to the right to improve visibility. So add padding and move it to the right. I think that's fine. A bit more. And now I can, similarly to the clinician use case, adjust the value range. For this statistical map, I know that the values are between 110 and 220. So let's plug these numbers in. 220, 110. Okay. One additional thing you can do to make the figure a bit nicer is to remove this black background, because the publisher then in the print of your article doesn't have to print all this black background. You can do this by setting all intensities below 15 in the MNI template to transparent. And now you can see on the right there's still a bit of black background because it's the padding. I have to do that separately. Where is it? Pad color transparent. Okay. And now a last thing, because we are printing on white paper, we have to change the color of the writing and the lines from white to another color. In this case, let's use black. Now it's harder to see on this background, but once we've saved it as, for example, a PDF, because PDFs are not restricted to a resolution, an image resolution. We can see it nicely on the white in the journal will be transparent background. And if you zoom in, you can see, because we use a PDF, the numbers stay nice and sharp, and you can actually recognize them in the PDF and change them using something like Inkscape afterwards. As coders or programmers, we are often faced with large data sets, and in the neuroimaging realm, these are often organized as bits datasets. I can show you one of these bits datasets. In them, each subject has an individual folder, and in it You can have subfolders, for example, anat for anatomical images or func for functional. And in those, there are the actual files. And to open them in NiftiView, you can easily just use a file pattern. And I can show you how to use it. So this is a parent directory. And now I can start with my pattern. As we can see here, it starts with a subfolder, then an anat subfolder, and then a .nii.gz file. So we will start with sub and then a wildcard for the pattern, then anat, and then another wildcard, and then the .nii.gz. And now each file pattern that meets or matches this pattern will be displayed. And as you can see, we have 1, 2, 3, 4 times 4, 16 images in this directory. And you can also see this makes quality control much easier, but because we have now already identified one anomaly. So this one is skull script and the other images aren't. And this I could annotate using the annotations by, for example, picking here 1 or 2. And then after going through my large data set, imagine you have 1000 images, saving my annotations as a CSV file, that's very practical. But we can even go one step further and also quality check pre-processings, because we have pre-processed this data set. As we can see in the derivatives ordner, there's a deep MRI prep subfolder, and deep MRI prep outputted 2 different files for each input file, one mask and one P0 indicating a tissue map. And we can also display that in a different view. Let's switch to view 2 and now change the pattern from dataset derivatives deep MRI prep, and I think there was an MRI subfolder. Yes. And we want to display the P0 files, so only the tissue maps. And now you can see here the tissue maps, and I can easily switch to the original input and thereby look at how well the pre-processing works. And also I could also annotate that using annotations and save them later. So very practical for large data and checking if pre-processing works. And the last 2 features I want to sell for the coder section, you can actually use the Python package NiftiView the app is built upon. This is much easier for people using Python. Instead of clicking around in the app, you can just use this code to get nice images and organize them. Use the different examples to fully grasp all the features that NiftiView offers. And you can also use the command line utility to create GIFs or images without even using Python, but just using the terminal. And finally, besides the NiftiView package, there's also the Nifty widget package, which offers you, if you are often using Jupyter notebooks, interactively using NiftiView just as you are used from the NiftiView app inside a Jupyter notebook, as you can see here. Okay, that's it for the NiftiView tutorial.